Good evening, everyone. Welcome to the Namana lecture series. Myself, Professor Pratima BK, Assistant Professor, Department of Electrical Engineering, will present a lecture on sensors and transducers. First of all, I want to thank our chairman, sir, principal, vice principal, my dear alumni, students, and Namana Trust for giving me this opportunity and nominating me for the Best Teacher Award. So let's start the lecture. So these are my contents. So I will be discussing about the transducer. I will be taking one transducer, which is photoelectric transducer, and we will discuss the applications of the transducer. So, what is a transducer? So, transducer is a device which converts one form of energy to the another form of energy. We see transducers in our daily life. So, for example, you can see the example of a microphone. So, microphone is a device which converts sound energy to the electrical energy. The loudspeaker. The loudspeaker is a device which converts electrical energy to the sound energy. And we can see the thermal scanner. The thermal scanner was used. The thermal scanner was used during the COVID pandemic. So you have seen that it is used to measure the variation in the temperature. And you can see the solar cells mounted on the buildings, the rooftops. The function of the solar cell is it converts the solar energy into the electrical energy. And in the hospitals, we can see ECG. It is used to measure the heart rates and it converts it into the electrical energy. The function of LED. LED is also a sensor. It is a light emitting diode which converts electrical energy to the light energy. There are many such examples, such as we can see the generators. So generators converts the hydro energy, the wind energy into the electrical energy. The electrical motors which converts electrical energy to the mechanical. The light bulb which converts electrical to light energy. We can see the pH meter. So pH sensor is a device which is used to sense the pH content in the liquid. So it senses and tells whether the liquid is acidic or basic. And we can see the dish antenna. So dish antenna will be taking up the electromagnetic waves from the free space and it will connect it into your electrical energy. And we can see many more applications like the applications such as touch screen of the mobiles, the biometrics, and we can see the sensors used in washing machine, oven, and many more. So basically, the transducers are of two types. So broadly, we can classify it as electrical transducer and mechanical transducer. So the function of the electrical transducer is it converts non-electrical energy to the electrical energy. The best example for this is microphone. The function of the microphone is to convert the sound energy to the electrical energy. The opposite process is of the mechanical transducer. It will convert the electrical energy to non-electrical energy. So the example for this is loudspeaker. So loudspeaker converts the audio electrical energy to the sound energy. So the components of the transducers, there are basically two main components of a transducer. So first component is a sensor and the second component is a transduction element. The function of the sensor is it will detect or sense the change in the physical quantities. So physical quantities may be of force, it may be pressure, it may be heat, temperature, and some chemical variation. So these all non-electrical energy, the physical quantities will be sensed by the sensor. And the sensor output is given to the transduction element. So the function of the transduction element is to convert the sensor output into the electrical form. The transduction element may be the Wheatstone bridge, it may be amplifiers, it may be the oscillators which converts the signal to the electrical form. So if you see some examples of the transducer circuit, so strain gauge is one of the transducer which converts the physical parameters such as force, pressure into the electrical energy. The strain gauge is a device or a transducer which is made up of a metallic wire, and when the force is applied on the strain gauge, the resistance of the strained metallic wire will be varying. So there will be change in the resistance. That change in the resistance is sensed by the sensor, and that change is given to the transduction element. So the variation in the resistance will be converted to the electrical energy by transduction element. Okay. Similarly, we are having a thermistor. So thermistor is a device which is used to measure the variation in the temperature. So thermistor is a device which is made up of semiconductor material. So the property of semiconductor material is the resistance changes with the variation in the temperature. So if there is a variation in variation in the resistance is sensed by the sensor, and that change in the resistance is given to transduction element which gives the electrical energy as a voltage. So there are many transducers. We can see there are resistive transducers, inductive, capacitive transducers, effect transducer, many transducers. But today I will be considering photoelectric transducers. The function of the photoelectric transducers completely depends upon the photoelectric effect. So photoelectric effect is, it takes the input as your electrical energy, light energy, and converts it into the electrical energy. And the photoelectric transducers are used to sense the object, the presence or the absence of the object, and the distance of the object also by making the use of light. So the photoelectric transducer consists of three main basic elements. One will be your emitter, second one will be your this receiver, and the last one will be your electronic components such as amplifiers. So the emitter consists of a light source, so such as LEDs or laser. So the function of LED or laser is, input to this will be your electrical energy, the output will be your light energy. And another component is the photodetector. Here the photodiode or phototransistor is used as a photodetector. The function of the photodetector or photodiode is, the input of this will be a light energy and the output will be the corresponding electrical energy. And the supporting element, that is the amplifiers, is used for strengthening the signals. Okay. So we will see the types of the photoelectric transducers depend on based on the sensing property. So there are three types of photoelectric transducers. First type is called as through beam. Second type is called as retroreflective. Third type is called as diffused photoelectric transducers. So we'll go through it one by one. So if you see this through beam photoelectric sensor, it consists of emitter and the receiver which is connected separately. So here it is used to detect the presence of the object which is moving here. So and the light will be emitted by the emitter and the receiver will be detecting the light which is emitted by the emitter. Now, when the object is passed through that, the light will be obstructed by the object and the receiver will not receive any light. So, the receiver section will be off, detecting that there is some object. So, this is your through beam photoelectric sensors. But there are some advantages and disadvantages of this. So, if you see the advantages, it will offer the longest optical range. It will sense the object which is in a longer range. And the color of the object being detected have no effect on sensing. So there are some disadvantages here because the setup is that there is the separate the emitter and receiver has to be connected separately. So there will be a separate wiring. So the design of this will be complex and it will be expensive. And the alignment of transmitter and the receiver can be difficult. So if we see the second type, that is retroreflective photoelectric sensors. So if we see here that the emitter and the receiver is in a single case, but at the other side we have to place a reflective mirror. So here also it works similar to the first one, that is through beam. So the emitter will be emitting the light continuously and the reflector will be reflecting the light which will be received by the receiver section. But when the object comes here, the object will obstruct the light and that the receiver will not receive the light and it will be off. So if you see the advantages here, because the emitter and receiver are in only a single casing, the wiring will be required at only one location. The operation is not greatly affected by the color and the range of the object or the targets. These are good for transparent, large, reflective objects as well as objects which are moving quickly. But the disadvantage of this is the sensing object with mirror finish, it cannot be detected. Okay. So we'll see the third one, that is diffused photoelectric sensor. So here also the emitter and the receiver is in only one case. Here the emitter will be transmitting the light rays continuously. But here when the object comes here, that object only reflects that light back and the receiver will be receiving the light. So this is then when the object comes here, the sensor will be off here. So the advantage of this is the sensing distance ranges from several centimeters to several meters. Because here also there is the emitter and receiver is only in one single case, so there will be easy mounting adjustment and the wiring also becomes easier. It can detect multiple and translucent objects also. The disadvantage of this is the sensing can be affected by the color, texture, dirt and other factors. Okay. So now we'll see some of the applications of the photoelectric transducers. So there are various applications of photoelectric transducers. So we can see one of the application, that is it is used in a smoke detector. So you can see the smoke detector. The function of the smoke detector is it is used to detect the smoke in the environment. If you see the diagram of a photoelectric smoke detector, it consists of a LED or a light source. At the other side, it consists of a photodiode and it consists of some indication, that is buzzer or LED. Here, this smoke detector, it actually works on the third principle, that is the diffused one, third principle of the operation of the photoelectric transducer. Here, the LED will be continuously emitting the light. The photo detector will not detect the light here because it is continuously emitting the light in a straight direction. But in the second picture, you can see here, when the smoke enters the smoke detector, the light rays get scattered. So when the light rays get scattered here, that light rays will be captured by the photodiode or photodetector and it will give some indication. The buzzer will be on, which indicates the presence of smoke in the environment. So this is one of the application. And if you see the next one, it is also used for liquid level detection. So it may be used in the liquid level detection, like in the industries, in the power stations, so thermal stations and all. We require to check the liquid level. So here also it consists this. If you see here that it consists of a LED, that is a light source, and at the other side you are having a photodiode. So here LED will be continuously sending the light energy, that is light, to the other side, and the photodiode will be detecting the light. But at the second, in the second diagram, you can see when the water level raises, the light which is emitted by the LED is absorbed. It gets absorbed. Therefore, the light which is going at the receiver, the intensity of light get decreased. So there will be a output of the receiver will be less, indicating that there is a level, there is a rise in the water level. So this is one of the example, and many of them have seen this application, that is automatic sliding doors in the entrance of a train or malls. So you can see here that at the entrance, at one side there will be a LED and the other side there will be a uh, photo detector. So continuously the light will be sent from emitter to receiver. But when a person enters, that light will be obstructed. So when light is obstructed, it gets the information that the door has to be opened. So this is one of the application, and if you see, as many of them have seen this money counter machine in ATMs. So here in this block, that is in this machine, there inside this there will also be a LED and a your photodiode, and it will be continuously sending the signals. When there is the flow of the note there, then the light will be obstructed and there will be a counting. The counting of the notes will take place when it is the light rays are obstructed. So these are some of the examples of your photoelectric detector. So if you see the summary here, I have covered the main operation of the transducer and the components of the transducer. We have seen the operation of the photoelectric transducer and some applications of it. Okay. So with the summary, I want to thank each and everyone who has given this opportunity for Namana series lecture. Thank you. Thank you everyone.